the outlet thermocouple measures the temperature again. Inlet temperature is subtracted from outlet temperature to determine how hot the water has become during its passage. Meanwhile, input electricity to the cell is monitored. During an experiment with a palladium cathode for the first week, while the cathode is loading, no excess is detected. Later, in a successful test, the outlet water temperature climbs, and total output energy from the cell exceeds input. This is called excess energy. Excess heat is measured at least 30 times higher than the background noise, often much higher. Professor George Miley, director of the Fusion Studies Laboratory at the University of Illinois, was one of the few editors of a peer-reviewed physics journal to accept papers on cold fusion.
Positive measurements of helium, continued reports of heat burst, the tritium measurements that people have done. While they're not reproducible always, the fact that they occur kept encouraging me. Let's take a tritium as an example, which is work that Tom Claytor has done at Los Alamos. At a meeting about a year ago where he was presenting his material, I asked him what I thought was a key question. Have you convinced your management at Los Alamos that tritium is real? Because it seems like such a convincing case. And he said, no, I haven't. I said, why not? He said, well, the problem is that I only get a positive results 3 times out of 10. Now think about that. If it happens once, the inquisitive scientists should say, well, how did it happen? Let's find out how we can make it happen again and how we can ultimately make it happen consistently.
The tritium work was the first indication to me that there was a reality. And then Claytor at Los Alamos also got positive results, and so did Howard Menlove. And they're people that I respect and could talk to personally. I then wrote a review of the field, looking at everybody's work worldwide, and talked to many of the people that were involved in the work. And on the basis of that review and personal knowledge of my own work and other people's, it became fairly clear that there was a very strange phenomena occurring here.
There is clearly evidence of anomalous excess heat which occur in these experiments under some rather difficult to achieve conditions, but rather well-defined conditions. There are also, in similar experiments sometimes, and rather dissimilar experiments sometimes, evidence of an anomalous nuclear process. And both anomalies are worth pursuing. It's my suspicion, my bias, if you like, that the two anomalies are in fact connected, that there's an underlying fundamental mechanism which connects the two. I would be satisfied with an accurate description of the method by which the lattice, the palladium crystalline system with deuterium inside it, how that crystalline system interacts with the nuclear process.
There is something new coming up, and so like everybody, professors who teach physics hate to change their courses. And generally, they don't appreciate monsters which crop up and which cannot be explained within the frame of the present knowledge.
Since prehistoric times, people knew that a certain amount of fuel always gave a certain amount of energy. Whether burning wood, coal, or oil, the process is a simple chemical reaction. Then in 1896, Henri Becquerel discovered radioactivity. He found materials that do stay hot for weeks. Later, Madame Curie and others discovered that some materials, such as radium, produce heat for centuries and even millennia. 1,000,000 times more energy can be produced by radium than by a chemical fuel weighing the same. It's been known since then that radioactivity not only produces heat, but never consumes the fuel. No change would be observed until thousands of years later, when the radium turned to lead, with only a minute amount of mass lost in the transfer to heat energy. Radioactive plutonium glows for decades, powering unmanned probes that venture out through interstellar space. If a cold fusion cathode were a typical chemical reaction, it would get hot and within a few minutes it would be consumed. The reaction would stop. In fact, there are no known chemical fuels in the cell. It contains mostly water, which is chemically inert. Water cannot burn. Yet in experiments, cold fusion heat has continued for days, sometimes weeks. The only thing modern science knows that is consistent with this is a nuclear reaction. However, it is conceivable that there may be a process even more powerful than nuclear reaction that physics does not yet understand. That is the mystery of cold fusion. For though scientists have identified telltale nuclear changes in cold fusion materials, they cannot agree on what exactly is this reaction or set of reactions that produce excess heat.
There are various, at least 3 conflicting interpretations. One of them is just it's some property of hydrogen or deuterium inside matter, or it's a property of the particles themselves, which is revealed by the absorption within solid matter.
Well, our critics would say that the problem with cold fusion is that there is no theory to describe it. The problem is completely different. The problem is that there are far too many theories which purport to describe the same set of observations, and no more than one of these theories can be correct. So we are embarrassed with an excess of theories, which means that it's difficult for me, an experimentalist, to decide amongst the theories to see which one I should examine and test.
Inside the metal lattice exists a world so spacious and expansive that hydrogen atoms can nest in a virtually 1-to-1 ratio with each atom of palladium. This creates a metastable state, which can sometimes release enormous energy. But how that happens is what theorists like the late Nobel laureate Julian Schwinger, MIT's Peter Hagelstein, and other brilliant minds have attempted to explain, and therefore reliably predict.
It might have 10 to the 10th dimensions.
Still, the lack of a theoretical framework does not deter those who see the potential for commercial devices.
At the moment, 10 watts per cc is about the maximum we can get regularly. There are odd people here and there who claim much more, and I believe them, but how often can they get it? That's the point. Now, were we able to get 100 watts per cc, well, then we would have a fantastic, and reproduce it. Then we would have a source which would be better than any nuclear energy we've had so far, and also, of course, completely clean, because it produces helium, which is totally harmless.
This experiment very much follows along the thought process of Les Case. And behind me you see 5 different sets of apparatus. The big vessel here is one of Les Case's, he calls them footballs. It's a stainless steel vessel on a heating mantle set up in exactly the arrangement that Les Case himself is doing in New Hampshire.